No, it's not actually a Sony. It's an Astron RS-20M. It's a 20 amp, 12 volt power supply, actually 13.8 volts. Here's the problem. If I turn this unit on, you see the voltage comes up to about 14 volts. Now I'm only supplying this thing about 75 volts AC input. So if I ramp the voltage up, there's 90, there's 100, 105, 110, there's 115, and get ready for it. It goes into overcurrent protection, and the SCR clamps the output voltage at about 120 volts. So that's no good whatsoever. So it seems to regulate pretty good up until about 105 volts, and then it starts climbing. So let's go ahead and troubleshoot this thing and see if we can figure out what might be going on in here. I've already ordered some parts. I did some preliminary troubleshooting, but I thought I'd go ahead and make a video on this in case someone else is having this problem. So there's the back side of it. It currently has a couple of 2N6055 output transistors in it. Those are just the pass transistors, the voltage and current regulating transistors. Right above those are the two big stud mounted rectifiers. It does have two rectifiers. It is a full wave rectification system. So it claims 13.8 volts, 16 amps continuous, 20 amps intermittent current, 50% duty cycle, made in USA. So let's get the top off and take a look inside. Well, there is the inside view of it. As you can see, a big beefy power transformer and a small regulator board with a big old beefy capacitor. This one has a Sprague Powerlytic capacitor in it, 32,000 microfarads at 25 volts DC. And then as you can see, the output filtering capacitor right there. I'm not sure what the value is on that. There are the two big stud mounted rectifier diodes. And then up here is the amp meter. I went ahead and added this little pot right there and a switch so that I can switch between 5 amp full scale and 25 amp full scale. But let's go ahead and take a look at the schematic and see what might be going on. Once again, I've already troubleshot this. I've ordered parts. I just want to go ahead and show you what I found. So this schematic is for an RS-20A and an RS-20S. This is an actual RS-20M, but it's extremely, extremely close. So it uses an UA or an LM723 regulation IC right here. And what that does is it takes a look at this right here, which is labeled 2, comes into pin 3. That is the voltage reference feedback. It outputs a voltage on pin 10 that drives this TIP28 possibly, I'm not quite sure. Can't quite make it out on the schematic. But anyhow, that drives through this 39 ohm resistor and this 1N4002, the base of both of these big output transistors on the back of the unit. Now here they're claimed to be 2N3771s. My unit has 2N6055s in it. But what I'm going to do is go ahead and disconnect the emitter right here so it does not drive the base of these transistors, and it will check the voltages once again. Should be 0 volts if these transistors have no leakage whatsoever. So let's go ahead and unsolder that and check and see if we still have output voltage. So if you have one of these Astron power supplies and it keeps blowing the LM723 right here, U1, go ahead and install a diode, anode to number 2, and cathode to the collector of the driver transistor right here. It says Q1 on the board, but the print says Q2. There's some kind of discrepancy right there. So what that does is it keeps from backfeeding this U1 IC and blowing this out. That's why there's so many hash marks on the circuit board, because I've replaced that chip multiple times. Finally, I put a socket in it, and then I sat down and I thought about it. What's blowing this chip out? Well, if you backfeed this chip without any voltage right here, there's a separate power supply right here, D1 and D2, feed the chip power supply voltage. And if C1 doesn't have any voltage and this chip doesn't have any input voltage to it, and you feed an output voltage to it via the terminals on the back, it will blow this chip out. So what I'm going to do is go ahead and unsolder terminal number 4 right here, which is the base drive to the output transistors. All right, got that unsoldered. Let's just go ahead and pull it out. So it is out and completely free of the circuit board. Now let's power the unit up and see if we get any output voltage. We should not, if the output transistors are not leaky. Okay, you can see the lead right here is unsoldered to the base drive of the output transistors. Let's power the unit on now. And so I'm at 90 volts. And look at that, way over 15 volts. output as I raise and lower the voltage. So right there, 95 volts, and I've got 13.8 volts output right there. That tells me the output transistors are defective. Let's go ahead and pull them out and test them out of circuit. Just go ahead and give them a quick wipe down, get all the heatsink compound off of them. Well, we got most of it off at least. Okay, so with the voltmeter and the diode range, let's go ahead and check these things. Base to collector. I see a junction. Base to emitter. And I see a junction. Let's reverse bias them. So base to emitter. And I still see something. I should not see something reverse biased right there. How about collector emitter? I see a junction there. And I see nothing there. Let's check the other one. Base to collector, a junction. Base to emitter, I see a junction. Now reverse bias, base to emitter, I should see nothing. And I see something. Emitter to collector, I see a junction that way. What about on ohms? So I should see nothing from collector to emitter. And I see 427K and 115K on that one. 207K and 26K. Those things are bad. Let's go ahead and get the MK168 out and see what it thinks. Okay, so the leads are connected. Base number 1, collector number 2, emitter number 3. Let's give it a test and see what it says. NPN 123 is base collector emitter. ICEO is 1.64 milliamps. ICES is 0.48 milliamps. Beta gain 44 and forward voltage of 1.07 volts. That's not right. That is a problem. Let's test the other one now. ICEO 1.66 milliamps, that should be collector emitter open. ICES 0.57 milliamps, collector emitter shorted. Beta of 44 and a forward voltage of 1.06 volts. That thing is bad. Let's go ahead and test the new ones now that I got. So the schematic calls for 2N3771s. I've got some 2N3772s, which are just a higher voltage transistor. Let's go ahead and test those now. If you see numbers on the bottom, that means I've already tested them. We'll see if they're still close. I tested these like a year ago. Let's see if they're still semi-close. Well, that one says 48 and a forward voltage of 0.566 volts. None of this weird collector emitter open, collector emitter shorted stuff. So that one tests perfectly fine. 48 again, 565 millivolts or 0.565 volts. Tests absolutely perfect. Let's go ahead and pop these in. They both have the same beta gain at this point, so I'm very happy with that. Got both insulators cleaned up. We'll apply some fresh silicone heatsink compound to them. Okay, I think that looks really good. A little bit of heatsink compound oozed out of all directions on both transistors, which means they have a great footprint to the heatsink. So let's go ahead and fire this thing up without connecting that pin back to terminal number 4 again and just see if we get any voltage on the output. So once again, I am trying the Super Lube heatsink compound like I did on my Sony subwoofer. So far, it seems to be working just fine. It's a very light heatsink compound. It's not really thick and cakey like the pure white stuff is. So we'll see how this works. All right, so as you can see, the lead is still disconnected over here on the right-hand side of your screen. I have the AC input voltage at 80 volts. Let's power the unit on. And I get no output whatsoever. All right, so before I connect this lead, I want to make sure that I have basically 0 volts across this filter cap, and I have 0.4 volts. And the input to the LA723 is 0.129, 0.13 volts. So I don't have to worry about a spike in voltage. All right, board looks brand new after cleaning. So one modification in addition to this diode right here that I've done to this unit is I went ahead and added a full-wave bridge rectifier down here, but I'm only using the two AC input leads that are bridged together right there to the output lead right here. And so what that does is it prevents any voltage coming back from the binding posts from getting back into the unit, because I used to use this in a ham radio repeater station where I had a constant, like a car battery on the output right here being charged by the power supply. And if the power were to go off, this blocks any voltage from that battery from coming back into the unit. And you may have noticed I did add good quality binding posts to the back of the unit and to the front of the unit right here. So let's go ahead and give this thing a test now and make sure everything works just fine at full AC input voltage. All right, here we go. I'm going to run the voltage up very slowly. So it starts regulating right there at about 78 volts. There's 100, 110, 120, 130. There's 140 volts AC input. The transformer started to get mad at 140 volts AC, but other than that, everything is good. So we are at 13.93 volts, which I'm totally happy with. We're at about 119 volts right now. Let's go ahead and bring the voltage down and see where it starts to drop out. So right there is 70 volts AC input. And it regulates good at about 75 volts. And once again, I'm up to 120, 130, 140, 145 right there. Stays at 13.93 absolutely perfectly. I certainly hope you enjoyed this video on the Astron RS-20M power supply repair that went into overvoltage periodically. Go ahead, leave me a question, a comment, a concern down below. I try to respond to the comments when I have time. While you're down there, hit that subscribe button and like this video. It really does help my channel grow. You can follow me on social media, Facebook, Instagram, Twitter at NorCal715. You can email me norcal715videos@gmail.com. Please be patient. I do have a full-time job and I do this in my spare time. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everyone have a great day. Once again, thank you so much for watching this video. I really do appreciate it. Bye-bye.